Okay, so today we're going to start a new shape. We're going to start today with cones. And so I want you to take a minute and pause and look at the beginning of this note packet and see how many of these blanks you think you can come up with. And then we'll come back and fill them in just a second. So I hope you were able to come up with the first two blanks, that the base of a cone is a circle and that has a single vertex at the top. What is interesting about a cone is where exactly would you guess that the height of the cone would be? Because you have on the cone, you have this going up the middle, and it is labeled with an H, so maybe that's obvious, but then you also have this measurement here. And as we think about finding the surface of a cone, the outer party hat, if you will, would you think you would need the red or the blue? And so it turns out there's actually two different kinds of height on a cone. So you have something that's called the slant height. And perhaps that makes sense to you that it would be called the slant height because it's slanty, right? It's diagonal. Versus you have it's just called plain old height, which is what we're used to thinking of with other shapes, is the one going up the middle, the one that's perpendicular to the base, right? So it goes from the vertex, starts at the vertex, and is perpendicular to the base. Is the actual height. Okay, so which one would you guess that we would need for surface area? Well, I hope you're thinking that we would need the slant height because that's the one that is on the surface of the outside of the cone. So just like we've seen before with other shapes, there's two types of cones. You have right cones, and then you have the slanty one, the oblique cones. And so the difference is one is slanty and one is straight up, right? And what segment represents the height of each type of cone? Well, if you're talking about the traditional height, your height is still going to be perpendicular to that base. It might be in a different location. It might not connect to the center of the circle. So this gives us a new term. A cone also has an axis. It has a line about which the entire cone is centered. And so in a right cone, the axis and the altitude, they're the same thing, right? It's the center of the cone, that line. But on an oblique cone, what's necessarily the line going up the center is not the same as the line that's perpendicular to the base. So this one's the axis and this one is the altitude. All right, so which segment represents the height of each cone? That would be the altitude. It's always the one perpendicular to the base. Okay, and is the slant height in the same or different locations on each type of cone? The slant height here and here, it's in the same place, right? Same location. Okay, so now what you're going to do is you're going to do this investigation with me, in which we literally look at something like a party hat and come up with the lateral area and surface area of a cone.